Hi everyone, this video is going to help with 11.7 in Algebra 2 or any class that's learning the standard deviation. So this might be used in a different class. Standard deviation. All right, and this is 11.7 for Algebra 2. All right, so let's talk about what standard deviation does. So standard deviation is a measure of how spread out data is. So spread out means like, okay, if I start from 0 to 5,000, are those my numbers that I'm looking at? Are they 1 to 2? Like how spread out are your data? So it's really helpful to look at standard deviation when it's comes to testing for schools. So I look at it all the time because I can use standard deviation to decide how spread out people's scores are. So the more deviation I have, then I look at what I'm doing and what I'm presenting online and how I can change that. So some sections have a real small deviation that from on the homework. And that tells me everyone's grades are really close together and typically they're in the BA range. So that tells me almost everybody got that topic. When it's more spread out, that tells me not as many people understood that and they aren't together as much. And there could be other reasons for that as well. But that's kind of what the idea of standard deviation is. Also, variance is another thing that measures how spread out data is. And variance has a symbol that looks like this. And standard deviation has a symbol that looks like this, like a sigma or a sigma squared. So variance is also how spread out a data is. And so they're both kind of looking at that same thing. And we also know what mean is already. That's the average of data, or you add them all up, right? Add up and divide by amount. Or number, I guess would probably be a better word for that, not really amount, but a number of data. So mean is symbol is an X with a bar on top. So variance and standard deviation, I didn't give a definition for because all it is how it shows like how spread out data is. All right, so let's look at some formulas. We know how to find the mean. We've been doing that since middle school, but the standard deviation and variance are a little different. So variance's formula looks like this. It's going to look kind of crazy. That is the formula for variance. Now check this out. This is the formula for standard deviation. What is the difference between those two formulas? Right? One's got a square root, one doesn't. That's it. So when you're finding the standard deviation, you actually find the variance first, and then one more step is that standard deviation. So it makes sense that we learn these together because their formulas are almost the same. So variance, I don't ever really look at the variance other than, I guess to kind of see how spread out that is, but normally I look at the standard deviation. So I think you'll see this more often than you will the variance, but either way, we're going to learn them both. Let's decide what in the world are these ugly symbols and what does it mean? We all know what square root means. Sum, that's what this means, right? So the sum of the data are x minus the mean. So we're going to add those all up and square them and divide them by the number of data there was in that set. So let's make sure we know x is just the number, the data number. So if we're talking grades, it would be the scores, the actual data. And then n is the number of data. So that might be like there were 50 students I was taking the data from, so 50, the total number. And then we know x bar, and then we know that this means sum. add up, right? So sum means to add up things. So let's look at how to calculate this, and then I'm going to show you. So in section 11:10, they do standard deviation again, and I'm going to show you a little more in this section that you could carry on and watch the virtual nerd video for the next section and be able to pick it up. Okay, so let's look at my first example here. What if I have just a couple numbers, because this formula is actually pretty time consuming. So let's look at these 1, 2, 3, 4, 5, 6 data right here. I have my mouse in my way here. All right, so if I have these 6 data and I want to find the variance and the standard deviation, how would I do that? Well, I'm going to use a little chart to help me. But first, you're always going to have to find that mean, right? So that means we have to add up all the numbers and divide by how many. What do we divide by? 1, 2, 3, 4, 5, 6. So we're going to divide by 6 and then add up the numbers. So 12, 3, 15, 16, 17, 21, 26, 4, 5, 6, 33. So I got 33 total data for, total numbers for what they add up for. Then what I do is divide to get that mean, which is 5.5. If it's like a decimal, go out a couple places to make sure don't round to the nearest number, but go out a couple decimal places just to make sure you don't make any mistakes. So let's go through how to kind of do the standard deviation by hand. So the first row here that I have is just going to be my x values, and we have 6 of those. Okay, so we have 12, 3, 2, 4, 5, and 7. So you have to list all of your x's. And then the next step would be to do that x minus the mean. X minus the mean. And so I'm going to take that mean, next row here, and I think I'll just go all the way across here. So, oops, you can't see me for a sec, but that's okay. I'm just making it pretty because I'm obsessive about making things pretty. All right, almost there. So my first goal is to subtract those. So I know the mean's 5.5. So I'm going to go 12 minus 5.5 is going to give me 6.5. And the next one is 3. 3 minus 5.5 is going to give me negative 2.5. And yes, you can have negatives. And 2 minus 5.5 is negative 3.5. And 4 minus 5.5 is negative 1.5. And 5 minus 5.5 is negative 0.5. And 7 minus 5.5 is going to give us 1.5. So I have all my x minus x bars. Now the next thing in our formula that we had, so we've now done x minus x, which is the mean. So the numbers minus the mean, and I have to square them, then add them. So the next step is to square each of these numbers. So you just times them by themselves, right? Or square. Either way that you want to think of that, that is going to make it x minus x bar, or x minus the mean, squared. So square 6.5, you get 42.25. I'm using a pencil with no eraser. All right. And then the next one, negative 2. All of these better be positive, because a negative squared is a positive. So if you put this in your calculator wrong, you're going to get a negative number, and it's wrong. If you say, okay, negative, which again is down here by the enter sign, way down here. So if you do negative, what are we at? 2.5 squared. you get negative answer. You put it in wrong. It should be negative 2.5 squared. Otherwise, you're telling it not to square the negative by not putting the parentheses around the whole thing. It'll only square 2.5 and keep the negative. So entering in this into your calculator, that's why I always say times it by itself is, you have to make sure you do it right. So negative 2.5 times 2.5 is 6.25. And negative 3.5 times itself is 12.25, and 2.25, and 0.25, and 2.25. So here are all the numbers squared. I don't know, I have all this extra room. The next step would be to sum them, add them all up. So we then add this row here. All right, so if I add up all those numbers, I get 65.5. And then I need to divide it by n. So then I take 65.5, and I divide it by 6. Remember, there's 6 total. That's our n, and I'm going to get 10.92. So let's again look at our two formulas, and where are we? We added them up, divided them by n. All right, let's look at our formulas. Add them up, divide by n. I am here. I've already got the variance. Square root it, and you get the standard deviation. So this is the variance. And then if you take the square root of 10.92, you're going to get the standard deviation, which was about 3.3, and this one would have been the variance. Okay, so there you go. There's the standard deviation. All right, this is not super easy. You'll notice I only did 6 numbers because you have to subtract the mean, then square them all, then add them up, then divide them, then square root them. So it's kind of a long process, but that's kind of the process by hand. I do want you to try a couple of them by hand. So a lot of the ones they give you, you can easily do by hand. What I'm going to show you right now is how to do this standard deviation on the graphing calculator and in Excel. So I'm going to clear off what I have. And here's my graphing calculator, and let's see here. I can see it better if I shade that somehow. There we go. I had to figure out where to hold it. Okay, so under here is the list and the stat button. This is kind of where we find everything. If you hit stat, and if you go into edit, that's the first thing. It's going to have a list here. So I'm going to go up to L1 and I'm going to push clear, not delete, be really careful, enter, so that I clear off all of those numbers. Then in L1, I'm going to enter all of these numbers I see here, the numbers from the beginning. I'm going to do 12, then 3, then 2, then 4, then 5, then 7. Double check you got them all in there, or you're going to get the wrong answers. Then, so I have my numbers in list 1. This only works for list 1. Then hit stat and go over to calculate. Under calculate, hit enter, and it says one variable stats. Well, you have to enter twice. Then you're going to get that X bar, that mean, the sum squared, and then you have, so the sum squared, and then you have this O symbol, this S symbol, and if I scroll down, I have the 5-number summary as well. That's the minimum, the quartiles, the maximum, so you can scroll up and down. Here's what we're interested in. S is a sample deviation. We don't care about a sample. We want the real thing. That's the sigma, kind of looks like an O on the calculator, and we got 3.3. Well, that happens to be what we have on our paper, right? But I don't see variance because it's not on here. So you could take the sum of the squares. Well, that's not going to help you because it's not the sum of the squares subtracted. So just take the square, the standard deviation, and times it back by itself. So 3.3 times 3.3 will get you the 10.9. So if you need to go backward that way, you can. So let's say that again. So I went stat, and then into edit, and that made the list. So I put the numbers in the lists. Then I hit stat, go over to calculate, go into the first one variable stat, and hit enter again to tell it to do it, and we can find the standard deviation. If you don't have one of these calculators, well, let's show you a different way. Okay, so let's go into Excel. And you could do this a couple ways in Excel. You could just enter the numbers in and make it subtract and do the hard parts for you. That's kind of a cool way to do it, and that's fine. I wonder if, I don't think it does. Okay, so I'm not so patiently waiting for this. There we go. So let's go ahead, and these are going to be our X numbers. So we have 12, 3, 2, 4, 5, and 7. Okay, so from here, what we're going to do is we're going to go to the end, or wherever you want to go, and I'm going to hit f of x, that's insert a function, and I'm just going to say standard deviation, and go, and it's going to come up with a bunch of things. Now there's different kinds of standard deviations. So I want to go to the one that has, I calculate standard deviation based on the entire population. Field criteria. I don't know if that's the right one. Based on, I think it's this one. Now I lost which one. This function. Okay, so ignores based on the entire population. So we want the standard deviation that's based on the entire population. Otherwise, it's going to be close to the right number, but off, and you're going to wonder why. That's called a sample deviation. So let's try this one, and it says to go from 2 to 7, A2 to A7. Okay, and we got our 3.3. Okay, so STDEVP. The P on there is kind of a big deal. So that's how you find the standard deviation in this program. Or, you could easily say equals this number minus 5.5. Enter. And I think this would do it right. Yep. So then we get all those numbers by just scrolling it down. Remember, you just click here, and all I did was subtract the 5.5 from 12, and then it did it for the rest of them. Then I'm going to say equals. Again, that's just a function, and I'm going to tell it, click this one, and I'm going to tell it to square it. That's above the 6. Square that number. Enter. And ta-da! Pull it down. Squared them all. Then I can go down here and say equals sum parenthesis of these numbers, and there's the sum. So you can use Excel just to make it quick if you can't find the standard deviation button. So then I take this sum, right? The next step would be to take that sum and divide it by 6. Divide it by 6, and there's the variance. Then take equals. Notice I always put equals to make it it'll add, subtract, multiply, and divide like a calculator if you put equal in front. So then I'm going to take this number and I'm going to square root it. Oops, I got to put square root. Square root is SQRT of this one. Enter. 3.3. Got the same answer. So that's kind of cool. One other thing, let's see. I don't think the other calculator will do the standard deviation. The one that I usually use is the whole. Desmos might. Setting plot points. Nope, this one won't do it. Desmos graphing calculator. It might. Desmos graphing calculator. I wonder if any of the other ones do it. You can play with these. Nope, this one doesn't do it either. Okay. Anyway, you could kind of play with what you have and let me know. Excel you all have, so I kind of try to lean towards something you all have. Or you can do it by hand. It's not that bad. Okay, one other thing I do want to make sure you see, and I have a pretty graph here. Why in the world do we learn the standard deviation? What good does it do us? And we'll study this a little more in that last section in Algebra 2. Maybe not in the other courses, so you might just not have to do this part as well. A lot of them do anyway. Okay, so here is a general bell curve, and what this is this tells us that the data is normally distributed, and that means like there's people in. If I'm talking grades, which is the easiest for people to think of, most people would be there's a couple people who have an F. And then the mean is typically around a C. And then you have quite a few people over here in B range. And then you have very few, but in the A range. So this is kind of how grades are. They're a bell curve. Lots of other things are a curve, normal curve as well. What we do with the standard deviation is we know the middle of this bell curve would be your mean. All right. And from that mean, you can subtract the deviation, the standard deviation one way, and add it the other way. And between those two numbers is 68% of your data. And I'll show you that on your numbers we just had. If I then take a standard deviation, which ours was 3.3, add it again, then we're going to get between those two numbers 95% of the data, and that's 2 deviations away, and that it picks up the 95. Then if I went out a third deviation, that's going to pick up 99%. So 1, 2, and 3 deviations, so you would add the deviation 3 times and subtract it, and you can then have all these numbers here for your data, and you could easily see how many people would be at so the 34 and 34 is the 68, right? And the 13.5 this way and this way would make us at the 95. But let's do this bell with the data that we currently have. Let's see how pretty I can make a bell shape. Hey, not bad. Okay, and the mean of ours was 5.5. And then let's go 1 deviation both directions. Maybe I'll go a little lower only with this line so I have a place to write the number. So 5.5 plus 3.3 was our standard deviation. That is going to go up to 8.8. 5.5 minus 3.3 is going to be at 2.2. So between 2.2 and 8.8, that has to be 68% of your data out of those 6 numbers we had. Then the next deviation, I'm going to make it a little lower. And I only did that because I just don't have any room to write the numbers. Okay, so then I take 2.2 and I minus 3.3, and that's going to give me negative 1.1. And then I take 8.8 and I add 3.3, and I get 12.1. Now this is 68, right? And then this would be 95. So 68% of the data is between those two numbers. 95% is now between these two numbers. So let's go out that one last little third deviation. So I'm going to take 12.1 and add the 3.3, and I'd get 15.4. And I'll take negative 1.1, and I'll subtract the 3.3 and get negative 4.4. And now these two numbers will pick up 99%. So 99% of the numbers on that example are between these two. Now, where would I use this? Well, if I'm giving a test and I want to know, well, 95% of the class is scoring between, let's say it was a 60 and 70 instead of these two numbers. Well, I would be like, wow, that's kind of low. Everyone's not doing well. So I can look at how spread out that data is and where the majority of the people are. So all you're doing is taking the mean, add, the same, that standard deviation. Subtract, subtract, subtract. And that tells you tons of information. Now you can still know that like half of the data is above 5.5. Okay. Half the data is below that. And you could find different numbers than the 68 based off of this little chart here because of the 34, 34, and so on. So you could be looking at a little bit different than the actual 3 different deviations, 1, 2, and 3 deviations away. So don't let that part confuse you. All right, so there's kind of the idea of standard deviation and how in the world do we use it for spread out on the data. We can use it with those normal curves. Okay. Now they don't have to be normal in order to find the standard deviation, but they do need to be a normal for this 1, 2, and 3 standard deviations away. All right, hopefully this video helped.